g of x, which is basically f composition of g. That's how it is known, but that's how you write it, FOG of x. They want you to find this, or they want you to find GOF of x. Either they want you to find in composition, either they will want you to find this or this. And note in this thing, my FOG of x is not equal to G of f of x. They both are not the same thing. They are different. They are different. And how do you do it is, just a second. Okay, how do you do it is, suppose I say you have to find FOG of x. I say you have to find FOG of x. How do you do it is, keep the first term as it is, f as it is. Change this O to a bracket and then write whatever is gx. And solve backward. First, you will know what your gx is. Replace here and replace that in fx. Example, I'm going to take example here. So it says, suppose that fx is equal to 2x square minus 3 and gx is equal to 4x. They want you to find a FOG of x. Second, they want you to find FOG of 1. They want you to find these two things. Again, they ask me to find FOG of x. So I know what they're asking is f, O will change into bracket, and whatever is after bracket, I'm going to write it like this. Is equal to. Let's solve. F will remain as it is. Let's solve the bracket first. Gx. Inside the bracket, I have gx. What is gx? It is given in the question. Gx is equal to 4x. So put in place of gx as 4x. Now what I have to find is f of 4x. I know what is f of x, but I need to find f of 4x. So what I'm going to do is, in f of x, wherever I see x, I'm going to replace my x with 4x. So what does it become? 2 times. I see x, right? So I'm going to replace my x with 4x in bracket. And then there was a square, minus 3. Solve. 2 times 4x square becomes 16x square minus 3, which is 32x square minus 3. Any question with this thing? Anyone who did not understand how to find FOG of x? Anyone?
So we're just plugging in the f with the g, and then we're just transferring that to the f column, right?
Yes. So basically FOG of x means in f you're plugging in g, whatever g value is given. So in f I'm putting in gx. Yes. Any other question, anyone? So now you found FOG of x. They are asking you to find FOG of 1. So whatever you found in FOG of x, replace that with 1 here. You get 32, 1 square minus 3, which is equal to 32 times 1 minus 3, which is 29.
I don't think that's 1. Because if you're going g of x, wouldn't the 1 go to the 4x?
No. You're replacing here. See, FOG of x you found. This is your final answer, right?
Okay.
You just replace in your final answer 1. That's it.
So you're not plugging it into 4x?
No. You can do it. If directly they're asking you to do this, then you can do it. But I would suggest you to go all the way this and then do it.
Can you break down f of g of 1 into the, like, kind of like how you did f of g of x equals
yes,
f
you can do that.
G.
Yes, let me show you how you can do that. Suppose I say here, let's see. So let's see here. So you had, so they're asking you to find f or g of 1. Okay. So basically they're asking you to find f of g of 1. I don't know what is g of 1. What I do is in gx, whatever is gx was given to you. In this case, gx was 4x. So if I put 1 in g, what do I get? G of 1. Let's solve. G of 1 is equal to what? 4 times 1, which is 4. So I'm going to replace here 4. It becomes f of 4 now. I need to find f of 4. Now how do I find f of 4? Is in fx. Wherever you see x, you're going to replace there 4. You get 4 square minus 3. It becomes 4 and minus 3. It becomes 32 minus 3, which is 29. You're still getting the same answer. It's just that you had to do much more steps. When you already found this thing, you could have replaced it directly 1 and found the answer. Both ways are correct. It's up to you which way you want to do.
So it's just easier to reuse the problem at 8.
Exactly. It's just easy. Once you found it, f or g of x, just replace x with whatever they're asking you and find your final answer. Any other questions, anyone? Okay. Let's see one more example I'm going to give you, and I want everyone to do that by themselves. It's like, okay, for the same example, if I say you have to find g or f of x, I want everyone to find g or f of x for the same example. Everyone find g or f of x. Is Nicholas here? Nicholas? Nicholas is not here. Hawking? Hawking is not here. Carly?
Yes.
Okay. Can you give me the steps for g or f of x?
Yeah. First I wrote like g and then parentheses f of x.
Perfect. What does it become?
And then I put equals g parentheses 2x squared minus 3.
2x squared minus 3. Perfect.
And then you plug it into g of x, so it would be 4 times 2x squared minus 3.
Okay. What do you get?
And then it would be 8x squared minus 12.
Perfect. Done. Perfect. Can I have Jelena?
Morning.
Good morning. Hi Jelena. So you need to find g or f of -1. How do you do that?
So you would plug it into the equation we just got.
Okay, what does
So it would be 8 times 1 squared minus 12.
-1 squared, because I'm finding of -1. Yes.
Negative 1 squared.
Yes.
So it would be 8 minus 12.
Yes. 8 minus 12, which is
4.
4, positive or negative?
Negative.
Perfect, Jelena. Perfect. Any questions with this thing? F or g or f of x? Now I want everyone to find is f o f of -2. I want everyone to find f o f of -2. Axel?
Yes.
Yes. You're gonna give me step by step how to do f of -2. My fx is 2x square minus 3 and gx is given to be 4x. I want to find f o f of -2.
Is 2 parentheses 2x squared minus 3 parentheses.
So you are saying 2 parentheses
2 -2 squared, 2 parentheses again. Negative 2 end parentheses squared minus 3, another end parentheses, and
Wait. So what does it
square
become?
minus 3.
This is basically f of negative 2, right?
Yeah.
Okay. Let's find what is f of negative 2 first. I need to solve the bracket. Let's find f of negative 2. What do you get? 2 times...
2... Wait, one more time?
Yeah, what do you get f of negative 2?
2 times negative 2 squared minus 3.
Okay, which becomes...
Oh, we're solving. Oh, my bad. 5.
Yes. So I'm going to put in here 5. Now I need to find f of 5. What is f of 5?
2 times 5 squared minus 3.
Yes, perfect. Which is?
47.
Yes, exactly. Correct answer. Any questions? Anyone till this point? Anyone has any questions? Once you got this, I want everyone to find g of negative 1. Do it. G of negative 1. Find this thing. Alejandro.
Yes.
So can you help me with this one?
Yes.
Just give me the final answer. Do it and give me the final answer. What are you getting the final answer?
Is it 16?
16? Let's see. So you put here negative 1, you get negative 4. Yep. Negative 4, when you put here negative 4, what do you get? So first you need to find g of negative 1, right? G of negative 1 will become 4 times negative 1, which is negative 4. Then I need to put g of negative 4, which is equal to 4 times negative 4, which is
16.
negative 16. Negative 16. Perfect. Any questions, anyone, with the composition? Next thing what they are saying is, third part I want to go to is, okay, next thing they say is, you have to find the composition and you also have to find the domain. So you have to find the composition and you also have to find the domain. How do you find it? Suppose so, here it says fx is given to be x square plus 3x minus 1 and gx is given to be 2x plus 3. They are asking you to find f of g and g of f both. They are asking you to find this, and then it says then find the domain of each composite function. You have to find domain of each. How do you do that? How do you do this thing is, so let's first find f of g. I want you to find f of g of x. F of g of x means the same thing, which is basically f of gx. Find it and tell me the final answer. I want everyone to do it themselves. F of gx. Try to do it yourself, this thing. How to find f of gx. Is Jose here?
Yeah.
Okay. Jose. So how do you do it?
You're just plugging in your g of x into your f of x,
Yes.
where you put x.
What do you get?
So you're getting parentheses 2x plus 3 squared
Mm-hmm.
plus 3x parentheses 2x plus 3 minus 1.
Minus 1. Okay.
Yeah.
So when you solve, let's see what you get.
Yeah, just give me a sec.
Yes. This square, don't get confused with this square. This basically means you're multiplying this bracket twice. And then you can solve here. It becomes open distribute, becomes 6x plus 9 negative 1. I open. 3 times 2x is 6x. 3 times 3 is positive 9. And when you open this bracket here, when you open FOIL method, first 2x times 2x, 4x squared. Then last 3 times 3, 9. I inner 3 times 2x, 6x. Outer ones, you get 6x plus 9 negative 1. When you solve x squared, there is no other term x, let's say 6x, 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 which comes out to be 18x. Then constants, positive 9, 18. 18 minus 1, 17.
Is that a does not equal sign up there?
Where?
On the like on the second line of
This thing?
yeah.
No, that's a positive sign because you opened
Okay.
it. Yeah.
Okay.
I accidentally put equal to sign at that time. So that's what you found. But now they wanted to find the domain. We already did the domain part. How to find the domains. How do you find the domain for this thing? What's the domain for this thing? We did domain, right? How to find domain or no?
All real numbers?
Yeah. It's all real numbers, but did I do domain part with you guys or no?
What did
I did not do domain part in chapter 2 and 3.
for
these
quadratic?
Oh, I never did domain with you. So, okay. Okay, for domain, I want you to under domain usually is all real numbers. Domain usually is all real numbers except in 3 cases. In general, the domain is all real numbers except few cases. 1, 2, 3. First one, if there is a denominator. If there is a denominator, then my domain will change. Second is, if there is a square root in the numerator. And third thing is, if there is square root in the denominator. So if you have a denominator, what you do is, these are the 3 things in which my domain will change. Other than that, my domain is always all real numbers or negative infinity to positive infinity. That's my domain, always. If there is a denominator, what you're going to do is, you're going to put denominator not equal to 0. You will put denominator not equal to 0. If there is a square root in the numerator, note in the numerator, this is important. Whatever is inside square root you're going to put it greater than equal to 0. Not this equal to is important. Equal to sign is important if it's in the numerator. If it's in the denominator, the square root, whatever is inside square root, strictly greater than 0, because my denominator cannot be equal to 0. These are the three things. So now let's go back to this problem here. We have to go back to this problem. I want to find the domain for this one. I said in general it's all real numbers, negative infinity to infinity, except these three cases. If there is a denominator, I don't see any denominator here. So definitely it's not the first one. What about the second one? Square root. I don't see any square root. So second one does not apply. Say square root in the denominator. No, it's not there. So I know my directly answer is negative infinity to infinity. But make sure when you're checking for f or g of x, if you're generally checking for domain of f, if you're generally checking the domain of g, you have to combine all the conditions of f, g and whatever you're getting this thing. That will be the final answer for f or g of x. So in this case, the reason it is negative infinity to infinity is not just this thing. The reason it is also negative infinity to infinity is, so you can write here, because, so this is another box, okay, this is separate, I did. So you can write here, because the domain of both f and g is negative infinity to infinity, the domain of f or g of x is negative infinity to infinity. So you have to look, you cannot say, oh, just you see at the f or g and say, oh, it's negative infinity to infinity. No, you have to look at your f and g also to see what's their domain. Then only you can find the domain of f or g of x. I will explain you why it happens. Why you have to look at f and g to find the domain of f or g. Similarly, you can find g of f. Let's find g of f. Suppose I have to find in this case of g of f of x. I want everyone to find g of f of x. Fx was given to you as x squared plus 3x minus 1 and gx as 2x plus 3. Find g of f of x. And one die.
Hello.
Hello. Can you tell me how to do this one?
Yes, okay. So I did the g parentheses of f of x,
Okay.
and then so it'd be g in parentheses 2, wait, no, g with parentheses x squared plus 3x minus 1,
Okay.
and then you would put that into the f.
Okay.
No, the g.
Okay.
Wait, the f, g, oh geez. Wait,
So what do you get?
you would do g 2 x squared plus 3x minus 1 plus 3. That'll be 2x squared plus 6x minus 2 plus 3. That'll be 2x squared plus 6x plus 1.
Okay, what's the domain of this thing?
Yeah, right? Oh, is there more?
Yeah, what's the domain of this thing?
The domain Infinity.
See, does it have a denominator?
No,
Does it have a square root?
no,
Okay, what about these here? Does it have denominator or square roots? Any of these?
no.
So it's negative infinity to infinity.
Gotcha.
Only if you have denominator, then it changes. If it does not have a denominator, it won't change. Let's do one more example. Suppose you are given f of x as 1 over x plus 2 and you are given gx as 4 over x minus 1. They want you to find two things. They want you to find FOG of x and they want you to find FOF of x and they want you to find the domain of both of them. These are the three things they want you to find. Can I have Daniel? Is Daniel here? Start doing FOG of x, everyone. Try to find yourself. Is Daniel here? No. Gerald?
Yes, I'm here.
Gerald is here?
Yes.
Gerald. Okay, so I need to find FOG of x. Can you help me with that? Yeah.
So for f of g of x, that would be, let's see, you do 1 over 4 over x minus 1.
So let's first write, what is FOG of x?
F of g of x is
F of?
f
Parentheses.
parentheses g
Okay, and then
parentheses x.
parentheses x. So now what is my gx?
Your gx is 4 over x minus 1.
Okay, I write it there. Now I am given f of x. I need to find f of this thing. How do I find f of this whole thing?
You plug in 4 over x minus 1 where x is an f of x. So you would have 1 over 4 over x minus 1
Okay.
minus 1.
Plus 2. There's plus 2 here.
Oh, I'm sorry, plus 2.
So let's solve here. How do you make it, how do you solve this thing here? Do you know how to solve this, Gerald?
You would have to rewrite the fraction.
Yes. So what is
So you would end up getting something like
2 over 1 right now, right? It was 2 or 2 over 1 is the same thing. I need to make the same base. How do I make the same base? Here I have x minus 1. Here I have 1.
So you would cross multiply,
Yes.
right?
What does it become?
So you would have
Cross multiply. 4 times 1 becomes
4.
4 plus
So you would have 4 over x minus 1 plus 2 times x minus 1 over 1.
2 x minus 1 over x minus 1 times 1. You multiply these two and cross multiply, right?
Yes.
So what does it become? 1 over what? Let's solve this. You get 4 plus 2x minus 2 over x minus 1. Let's solve and tell me what is 4 negative 2?
So you would have 2 plus 2x.
So what does it become?
4 minus 2 is 2.
Yeah, so it becomes 2x. What is 4 minus 2?
4 minus 2 is 2.
2, yes. and then x minus 1. How do I write it as a single fraction, this thing, you know that? So basically right now, if you are confused by this too many division signs, I can write it like this, right? 2x plus 2 over x minus 1. How do you divide fractions is, if you don't know guys, you're confused with fractions, remember how do you do it is. So once you solve this, you're like, oh, there's too many division signs here. There is too many division signs. How am I supposed to solve this? Write it like this. Whatever is in the numerator divided by whatever you have denominator, write it like this. How do you divide it is, keep the first one as it is. Change the division into multiplication and flip the second one. So it becomes x minus 1 over 2x plus 2. And then just multiply. For multiplication, you just cross multiply. One times this thing gives me x minus 1. So basically 1 is basically 1 over 1. If there is no denominator, the denominator is 1. And you multiply, and for this thing you multiply like this. So this is your final answer. Now in this case you have to find the domain. For finding the domain, you need to see the domain of all of these. F or g of x, you have to look at the domain of this also. You have to look to find the final domain of f or g of x. You have to look at the domain of fx. You have to look at the domain of gx and this thing. Okay. So my fx was 1 over x plus 2. 1 over x plus 2. My gx was 4 over x minus 1. 4 over x minus 1. And then for this thing you have here x minus 1 over 2x plus 2. Now, to find the domain of f or g of x, you will need to find the domain of this one, and whatever is the second function, here it's gx. That's the only thing I need, and I need to combine those domains. I again repeat, to find the domain of f or g of x, I would need to find the domain of the final answer and the domain of the second function. Here the second function is gx, so I'm going to find the domain of gx and I will combine it. Okay, can I have Erica? Not a Joshua?
Yeah.
Okay, Joshua, let's find the domain for gx first. Gx is given to be this thing, 4 over x minus 1. How do you find the domain of 4 over x minus 1?
You could...
What happens, okay, in this case, first of all, I told you in general, the domain is all real numbers, negative infinity to infinity. Only except 3 cases. Do you see a denominator here?
Yes.
Is denominator a square root?
No.
Okay. Only if it's a denominator without a square root, what do you do is, whatever is in the denominator, here I have in the denominator x minus 1, I will put it not equal to 0. And then I will solve for x. Joshua.
So it can't equal 0, right?
Yeah, it cannot be equal to 0. If you have just denominator, you cannot put it equal to 0.
So x does not equal 1?
Yes. See, that's what we did here. I wrote here. If there is a denominator, whatever is in the denominator, put it not equal to 0. So I put it not equal to 0. And when you solve, you add 1 both sides, you get x not equal to 1. So my gx cannot be equal to 1. I cannot put x as 1 in gx. Because what happens if I put x as 1 here? It will make it 4 over 0, which is undefined. So my 1 is not included in the domain of gx. So from this thing I'm getting not equal to 1. Let's see about this one. Christopher?
Yes.
Okay. What about this one? How do you find the domain for this one?
Can you say that again? I can hear you.
Okay. We need to find the domain for this function here now. How do I find it?
I'm having a problem with my mic. Sorry.
Okay. You're not.
Can you like type it or something? I can't hear you.
I don't think it's just you. I can't really hear that well either.
Oh.
Might be Herman.
Are you getting it?
Domain of f of g.
Yeah.
None of us can hear you.
No one.
I hear you.
You cannot hear me at all. No one can hear
Your
me.
mic sounds muffled.
Wow. Wait. No one can hear me. See. Oh my god. What do I do now? Okay. What about you? What about now? Can you hear me?
Sounds better.
Better.
Can you hear me, Christopher, now?
Yes.
Okay. I need to find the domain of f or g of x.
Okay, so since it has a denominator, you have to set it not equal to 0.
Okay.
And then you subtract 2, and then it's going to be 2x is not equal to negative 2.
Okay.
Divide by 2 on both sides. X cannot be equal to negative 1.
Yeah. So how do you write your final answer is, there is two ways of writing your final answer. So my final answer will include this and this. It will also include the gx. Whatever you found the domain for gx, it will include that also. So how do you write it is, okay, all x, this has all x, this means all x, this line means such that, all x such that x should not be equal to negative 1 and x should not be equal to 1. That's how you write it. That's one way of writing. This means all x, this means, this line means such that, and this is the condition we are putting. That's how you write it. I mean, you don't have to write this thing, I'm just explaining in words. How do you write it? All x such that x is not equal to negative 1, x is equal to, it's not equal to 1. It can be anything except these two. That's what it means. So your book is just writing it this way, so I'm going to teach you just this way. But there is another way of writing too. So basically when you're finding the domain of the FOG, you're going to look at the final answer, whatever you got as your final answer. Also the domain of the second function. Not the first function, just the second function. Any questions, anyone? If any point you don't hear me, let me know. Okay. In the same problem, they want you to find FOF of x. Note my fx was given to be 1 over x plus 2. 1 over x plus 2. Can I have Hugo?
Yes.
Okay, help me find FOF of 2.
So what they want me to do is plug in f itself into the denominator of 1 over x plus 2.
So what do you get?
So it's going to be 1 over 1 again on the denominator 1 over 2 over x plus 2 plus 2 plus 2.
Okay. I need to solve this. Can you help me solve?
Yeah, so what I'm going to do is I'm going to multiply on the denominator, I'm going to multiply the denominator. So it's going to be x times x plus 2 times 2.
Like this?
And that's...
And in the denominator?
It's... I'm going to also multiply it, so it's x plus 2.
X plus 2. If there was 1, if there was nothing, there was 1, and then I multiply. Okay. What does it become?
So it's going to be on the denominator is x 2x plus 3.
Plus 3?
Yeah. But I guess I jumped. So it's gonna be 2 times x, 2 times x, 2 times 4. So it's gonna be 5
5, yes. Okay,
over x plus 2.
I don't want too many denominators. What does it become?
So I'm gonna divide it.
Yeah.
So it's gonna stand 1. Yeah. So I'm gonna flip it.
So it becomes?
And now, so it becomes 1 times x plus 2 over 2 x plus 5.
Yes. So what does it become, the final answer?
So my answer, it's going to be x plus 2 over 2x plus 5.
Okay.
I mean, 2x plus 5, yeah.
Perfect. Okay. Miguel? Is Miguel here? No? Angel?
Yeah.
Okay. Angel, can you help me find the domain for this thing?
Yeah. We set the denominator to 0.
So what do you do? What's the denominator?
2x plus 5 equal to 0.
Not equal to 0.
Oh yeah, not.
Yeah. And then?
And then we see, like, set it equal to 0, like,
yeah,
what x to be.
What do you get?
2x plus 5 equals 0, and then the end result will be 5 over 2.
5 over 2 or negative 5 over 2?
Negative 5 over 2.
Okay, you got this thing. What's my domain?
I believe is it negative infinity to negative 5 over 2?
So that I want you to write in this way. I want you to write in the bracket way.
Oh, okay.
All x such that x not equal to negative 5 over 2. What you found right now. Okay, that's your final answer? Angel, you have to look, okay, you find the domain of this thing, the final thing, but you also have to look at the domain of the second function. In this case, my second function is
yeah.
So find the domain for this thing also.
The original, so then it's also x can be negative 2.
Yeah, x cannot be negative 2. So it will be both of these conditions. Yes. Perfect, Angel. Any questions, anyone with the domain? Everyone got it? Okay. Yes, you can do it. Okay. Next, I'm gonna go to section 5.2. Section 5.2, page 267. Okay. Before going to this thing is what they are in this topic 5.2. You're gonna learn about two things: one-to-one functions and inverse functions. This is what we're gonna talk about today in this section. You need to understand what is one-to-one functions and what are inverse functions. You can find the inverse of a function only if the function is one-to-one. Okay. First of all, I say here, you're given these two things. Okay. I say here it's A, B, C, D. Here it's 1, 2, 3. Okay. My A is going to 1, my B is going to 2, my C is going to 3, my D is going to 2. First of all, whether this thing is a function or not. How do you check whether this thing given to you? This is my domain, because we are going from here to here, and this is my range. And we call it actually codomain. This is codomain. If you have to tell whether this thing is a domain or this thing is a function or not, it is a function it is a function only if every element of domain, note down, underline this word every element of domain is going to only one element of codomain. Only one element. Underline that. These are the two important things. You can say it's a function only if every element is going to something here. Note, A is also going to something, B is also going to something, C is also going, D is also going. Okay, first condition is met. Every element is going to something. But are they going only to one element of codomain? Only one element. Yes, A is going to only one thing. B is only going to one thing. C is also going to only one thing. D is also going to one thing. So it is a function. But what if I write it like this? I give you an example again. I give A, B, C, D. 1, 2, 3. I say A is going to this, B is going to, C is going to 3. Is this my function? Note, in this case, this is not my function. This is not my function. The reason this is not my function is because A is going to 1, B is going to 2, C is going to 3. But D is not going to anything. Note the definition said every element of domain is going. Every element is going. Since D is not going to anything, it is not a function. It is not a function. Also, if I give you one more example, I say A, B, C, D. I have 1, 2, 3. I say A is going to 1 also, A is going to 2 also. Then I have B going to 2, C going to 3, and this thing going to 2. Okay, each element is going to something. That's good. But are they going to only one term? Note, A is going to two things. It's supposed to go to one thing only. Since it's going to two things, it is not a function. Any doubt how to find what is a function and what is not a function? Each term of domain, first of all, each term should go to something. And it should go to only one thing. It should go to only one thing. It cannot go to two things. A cannot go to two things. It can go to only one destination. It cannot go to two destinations. Okay. Can I have Samantha?
Yes.
Yes, okay. I have here. Okay. Samantha, I'm giving this example here. Okay. You tell me whether this thing is a function or not. I'm given A, B, C. I'm given 1, 2, 3. My A is going to 1. My B is also going to 1. And my C is also going to 1. Is this a function?
Yes, it is a function.
Why is it a function?
Because the domain, it belongs to the range.
Yes. So A, see, how do you say it is? A, B, C is the domain, right? And all of them are going to something, right? That's one condition. And all of them are going to only one thing. Like A is only going to one destination, B is only going to one destination, and C is also going to only one destination. So it is a function.
Function as long as they go to
only one thing.
A destination. Yeah.
Yes, perfect. Any questions on what is a function and what is not a function? So let's come to one-to-one function. One-to-one function. One-to-one function means, so you can write the definition as, let's see, they have a formal definition here. They have complicated definitions. So you can say each element of domain is going to a different element of codomain. So my each element of the domain is going to different element of codomain. So this is not 1 to 1. Because A is also going to 1, B is also going to 1, C is also going to 1. They're not going to different ones. They all are going to the same thing 1. If they go to different things, they are 1 to 1. So example here, I say here, you're given these two boxes here. You're given these two boxes. Okay. One is age, one is cholesterol. Age they are saying is 38, 42, 46, 55 and 61. And then you have cholesterol as 57, 54, 34 and 38. 38 has cholesterol level this thing, 42 has this thing, 46 has 34, 55 and 61 have 38. Can I have Shaira?
Yes.
Is this a function?
Yes.
Okay. Is it a one-to-one function?
No,
Why not?
because it 55 is and 55 and 61 are going to a different element.
Okay, they're going to the same element, not different, same element.
Oh.
Yeah, they're going to the same destination. That's why it is not 1 to 1. Any doubt? Okay, next thing is, okay, there is something known as horizontal line test. Horizontal line test. What it says is, if every horizontal line looks like this line. This is a horizontal line. If every horizontal line intersects the graph of a function f in at most one point, then f is 1 to 1. F is 1 to 1. Remember, we already did the vertical line test. Vertical line tells me whether my graph is a function or not. Horizontal tells me whether it's 1 to 1 or not. Vertical tells me whether it's a function or not. Horizontal tells me it is 1 to 1 or not. How do you check it? Let's take an example. I'll show you here the book. If you have the book, I want everyone to go to page number 268. 268. So you're given this. So you see this one here, this graph here. I want to check whether this thing is a 1 to 1 or no. What I'll do is I'll start drawing horizontal lines. So when I drew this horizontal line, I see my horizontal line is touching the graph at 2 points. If it touches at any point, if at any point it touches at more than 1 point, it is not 1 to 1. Since here it's touching at 2 points, it is not 1 to 1. It is supposed to only touch at 1 point. It is only supposed to touch at 1 point. But since it's touching at 2 points, this is not 1 to 1. What about here? I'm drawing horizontal lines. I see it is crossing my graph at 1 point. This horizontal 1 point. This one. No matter how many horizontal lines I draw, it's only touching at 1 point. So this graph is 1 to 1.
So so the horizontal lines is just basically the vertical test, but for the range.
Yes. This is the range part. Yes. Any other questions? How to check whether it's a function is 1 to 1 or not? For whether the thing is a function or not, you do vertical test. For 1 to 1, you do horizontal test. Next thing they say is you have to find the inverse. Now it comes to finding the inverse of the function. So suppose you are given here, I'll see here. Let's see this example. Let's take this example. I can only find the inverse if the function is 1-to-1 function. Okay. So for that, first of all, can I have was? He's not here. Karen?
Yes.
She's here. Okay, Karen, this is my example given to me. Okay? Is this my function?
Yes.
Is it 1-to-1 function?
Yes.
Yes, it is function and it is 1-to-1 also, because each term is going to, first of all, each term is going to something and each term is going to only single thing. So it is 1-to-1 function and unique thing. Okay. Since it's 1-to-1 and it is a function, I can find the inverse. Okay, if I have to tell what's the domain of this thing, what's the domain of this function?
The states.
Okay, this all the name. So I'm gonna write Indiana.
Okay, Indiana, Washington.
Yes.
South Dakota, North Carolina.
Yeah,
yes,
North
and
Carolina.
Oklahoma.
So this is my domain. If I say what's my range?
6.6, 7.1, 0.9, 9.9, 3.9.
Perfect. That's my range. And you said this is 1-to-1 function. If it's a 1-to-1 function, I can find my inverse of this function also. Note, I can only find the inverse if it is a 1-to-1 function. Inverse function exists only if it is 1-to-1. I can do it. And how do I find inverses? Just interchange the place. My range will become my domain and domain will become my range. So now my box becomes like this.
Okay.
My population will become my domain and my state will become my range, as an example here. That's how you find. You just interchange the place. The population will become your domain and this will become your range. Eduardo?
Yeah.
So if I say find the domain for the inverse, what's the domain for the inverse? What's the domain for the inverse?
Sorry, I was trying to catch up and such.
Did you understand how to find, first of all, inverse? Eduardo? Eduardo, are you there? I cannot hear you, Eduardo.
Yes, sorry, my mic was muted.
So I want to find the domain of inverse. First of all, did you understand how to find the inverse?
Not enough.
Okay, so you just interchange the place. In this, I found in this, see here, in the first example here, this was a question given to me. Okay, so in this case, I see this is my 1-to-1 function. It's a 1-to-1 function. Why? Because each element here, each element from the first box is going to only one thing in the second box, and it is going to a unique thing. Indiana is going to 6.6, Washington is going to 7.1. They're going to unique destinations. So that means it is a 1-to-1 function. Since it's 1-to-1, I can find the inverse. Inverse by just interchanging the place. My population will come here and my state will go here. So this is the inverse of this function. Domain comes always from the first box. Range comes always from the second box. So what's my domain in this case? It will be 6.6, 7.1, 0.9, 9.9, 3.9. And range in this case will be all the states. Indiana, Washington.
I mean, the thing that I'm just being like, or I'm thinking of is the states, because how are we going to be putting that in a graph?
Oh, not in the graph. Not in the graph. You will be given like box like this. We are not graphing.
Yeah, because I was able to understand the inverse, but not for like where it's like the states.
Okay.
That's why I wasn't like answering.
Okay. Yeah, no problem. No problem. Yeah. So let's see another example here. Let's see another example here. I'm going to do this example here. So here if you see, it says find the inverse of the following one-to-one function. You're given it is a one-to-one function. You're given it is one-to-one function. By this thing, it's just written another way. This was one way of writing. Graphing was another way. This is the third way of writing. What does this mean is, negative 3 is going to negative 7. Negative 2 is going to negative 8. Negative 1 is going to negative 1. 0 is going to 0. 1 is going to 1. 2 is going to 8. And 3 is going to 27. That's what it means here. They wanted to find the inverse of the following one-to-one function. Let's find the inverse first. I want you to find the inverse first. Okay. Inverse. I want you to find the inverse here. Let's see here. Let's talk about inverse only. Okay. Can you tell me inverse, Eduardo?
The domain is gonna be negative 3, negative 2.
Okay, wait. I'm not asking the domain of the function. I want to find the inverse. For inverse, what you're gonna do is interchange the place. Interchange the place in the bracket. So it becomes negative 27 to negative 3. You interchange the place. Here it becomes negative 8 goes to negative 2.
Negative 8 to negative 2.
And then?
Negative 1 to negative 1.
Then?
0 to 0.
Then?
Then 1 to 1.
Then?
Then 8 to 2.
Yes.
And 37 to 3.
Okay. Now they wanted to find only the domain for the inverse. Domain of inverse. How do you find the domain for inverse?
You get the 27 or all the
first terms. Negative 27, then
8, negative 8.
Negative 8, negative 1, 0, 1, 8, 27. All the first terms. And what's the range of inverse?
It's going to be negative 3, negative 2, negative 1, 0, 1, 2, 3.
Perfect. That's how you find the domain of inverse and range of inverse. For inverse, basically you interchange the position. In this case, you had negative 3, negative 27. Interchange, it will become negative 27, negative 23. Similarly, change for each and every bracket. That will be the inverse. First terms will give me the domain. Second terms will give me the range of inverse. Any questions with this thing?
So is it kind of like just the domain and range are flipping a little bit, or?
Yes.
Okay.
Yeah.
So if they're asking inverse, you just flip the domain and range.
Yes, you can only do that because it is given. Note in the question it says the function is 1-to-1. It says already in the question. So I can do, if it was 1-to-1 function, I know it is a 1-to-1 function, I can do it directly. I don't have to worry about anything. If it's not 1-to-1, first you need to check if it's a 1-to-1. Once you check, then you can find the inverse. Let's do one more example here. Okay, now you are given a function. Okay, I will write here. Okay, the last topic for today, what we are doing is you'll be given a function and you have to find the inverse. There are 5 steps. There are 5 steps to this thing. Steps to find inverse of a given function. Step 1. Replace f of x by y. You're gonna replace f of x by y. Step 2. Interchange x and y. Step 3. Solve for y. Step 4. Replace y with f negative 1 of x. This thing is f of inverse. This is known as f of inverse. F to the power of negative 1 is known as f of inverse of x. And step 5 is check. How do you check is you're gonna find FO of f inverse. And you're gonna also find f inverse O of f. If they both come out to be equal to just x, that means whatever you found is correct. So these are the steps. Replace fx with y, interchange x and y, solve for y, replace y with f inverse, which is f to the power of negative 1. Then you will find composition of FO of f inverse and f inverse O of f. They should both come out to be equal to x. Let's give an example. So they say, let's see. We are given fx as 2x plus 3. I say find the inverse of this thing. Find the inverse of this function. Nick?
Can you use the paper a little bit?
Yeah. Nick? Is Nick here? Nicholas is not here? Okay, he's not here. Hawking? Okay. Jelena?
Yes.
Okay. Can you help me with this step by step? What's my step 1? Hello, Jelena?
Hello.
Can you hear me? Can you hear me?
Yes.
Okay.
Sorry, you guys froze.
It's okay. Yeah.
You guys keep freezing on me.
I don't know, it's my internet. I don't know. Is it for everyone I'm freezing or no? Okay. So let's see. What's my first step here, Jelena?
Okay, so you have to plug in your fx into your f of f.
No.
One.
Step one.
Oh, place f of x by 1.
By
so
y.
replace. So
By
it'd
y.
be y equals 2x plus 3.
Okay, that's my step 1. What's my step 2?
You're gonna interchange the x and the y. So it'll be x equals 2y plus 3.
Perfect. What's my next step?
Then you're gonna solve for y.
What does it become?
Becomes so
first you subtract 3. It becomes x minus 3 is equal to 2y. Then 2 is multiplying. I divide both sides by 2. I get x minus 3 over 2 is equal to y. Solve for.
Yes, there we go.
That's what you got?
Yes, that's what I got.
And what's the step 4?
Step 4, replace y with f of inverse 1.
Yes, f of inverse, I wrote it as, I replaced my y with this thing. I got this, right?
Yes.
Okay. Now next step 5. Can you help me with step 5?
Okay. I will try to.
Yeah. Let's do one by one. I want to find FO of f inverse of x. How do you do that?
So, going to plug in x minus 3 over 2.
Yeah.
So it would be f times x minus 3 over 2.
You're saying it becomes what?
Sorry, 1 second. Okay. So then it's going to, we're going to do f of, would it be x minus 3 over 2?
Yes. Which is equal to?
Hello?
Yeah, which is equal to?
It's froze again. Can you hear me?
Yeah, I can hear you.
Okay.
Yeah, you keep on saying, yeah. What's the next step after this?
Okay, so the next step, you're going to our f of x, so you're going to plug in our x minus 3 into our f of x. So it'll be 2 times x minus 3 over 2 plus 3.
Yes, perfect. Let's solve. What do you get?
I get
Multiply 2 inside. You get 2x over 2 minus 6 over 2 plus 3, which is x minus 3 positive 3, which is x. Note you are getting x. Similarly, you find f inverse O of f. Right now you found O of f inverse. You need to find f inverse O of f. That will also come out to be equal to x. If it is coming out to be equal to x, that means whatever you found is correct. Any questions with inverse? Anyone, any questions with inverse? Okay. I'll give you one example. I want you to find the inverse yourself. So, example, you have to find inverse yourself of x cube fx is equal to x cube minus 8. Find the inverse of x cube minus 8. Was Miguel, Erica, Daniel, Hawking, Nicholas, you're gonna give me the inverse for this one.
Next to the f, what is that?
X to the power of 3 minus 8.
Oh, okay.
What's my first step, Nicholas?
You switch the, you replace the f of x by y.
I replaced it. What's the next step?
Interchange the x by
Y and y by x. I did. Okay. I interchanged them.
I actually didn't write down step 3. That 4 and 5.
Okay, step 3 says solve for y. I need to solve for y. How do I solve for y? I need y on one side, everything else on the other side. How do I do that?
You add 8 to the x.
Okay, I get y cube is equal to x plus 8. I just need y.
And then you replace y with the f.
No. I need y. I don't need y cube. What's the opposite of cube?
Squared.
Square or cube root?
Cube root, yeah.
Cube root. So you're gonna take cube root on both sides. So here you get y is equal to cube root of x plus 8.
And then now you replace y with the f of x to the negative power.
Yeah, negative 1, which is f inverse, and you get your answer. If they want you to check, you check. How do you check is find FO of f inverse and find FO of f inverse O of f. You're gonna find both of them. They should come out to be equal to x. If they both come out to be equal to x, that means what you found right now here is correct. This is the checking part here. You have to do it yourself. I'm not doing it right now, this part. Any questions with the inverse? The last question for today I want to do is, if you're given fx as 2x plus 1 and x minus 1, x not equal to 1. And I want you to find the inverse of this thing. Eduardo?
Yeah.
Can you help me find inverse of this one?
So we put that into y equals 2x plus 1 over x plus minus 1.
Perfect. Then?
And then we switch that around, right?
Yes.
By putting it into x equals 2y plus 1 over y minus 1.
Perfect. What's my next step?
Is you try to multiply the y minus 1 to the other side.
Yes. So the reason here is I need to isolate y. You'll be like, oh, there is 2 y's here. There is 2 y here. I'm supposed to deal with that. No, let's get rid of this denominator here. I don't want to deal with denominators. Once you get rid of the denominators, it is good. Here this whole thing is dividing. It's 2y plus 1 divided by this whole thing. So what I'm going to do is I'll multiply both sides with whatever I'm dividing with. So I multiply with y minus 1. What happens? Here they cancel. Here they cancel. And here when you multiply, you are left with xy minus x is equal to only 2y plus 1 because they got cancelled. You will be like, oh, there is still 2 y's. How am I supposed to deal with that? What you do is take all the terms which have y on one side, all the terms which don't have y on the other side. This term does not have y. I'm going to take it to the other side. I add x both sides. I get xy is equal to 2y plus 1 plus x. I said I need to take all the terms which have y on one side. Here 2y. It is adding, so I'm going to subtract 2y both sides. You get xy minus 2y is equal to x plus 1. Now after this, after I have y terms on one side, all the terms which don't have y on the other side, what do? I take out y common from here. Since both terms have y, I take out y common. I needed y, so I take out y common. Okay. Gerald?
Yes.
After I took out y common, what I'm left with inside?
Sorry, could you repeat that?
I took out y from this thing. xy minus 2y. What am I left with inside? From xy you took out y. What are you left with?
From xy, take out the 2y, you said?
So here, see, you had xy minus 2y, right? They both had y
Yes.
in it, right?
Yes.
I took out y outside. I took out y because they both had y common. I took out y.
Okay, so then you're left with x minus 2.
Perfect. Yes. Now, I just need y on one side, Gerald. How do I do it?
You're going to divide the x minus 2
Yes, exactly.
from the left side and divide that from the right.
Exactly. So when you took out common, basically y is being multiplied with this whole thing. So I divide both sides with this thing. So you get y is equal to x plus 1 over x plus 2. Note, I solve for y. Once you solve for y, replace y with f inverse of x. That's
Why
it.
did they change to x plus 2?
Oh, it's x minus 2. I'm sorry.
Okay.
You're correct. It's x minus 2. Correct. Any questions, anyone? How I got this? So here, if you getting denominator, you are getting 2 y's. First of all, your first step would be to get rid of the denominator. Denominator means it's dividing. You multiply both sides with that. Try to solve. Once you solve, you got this thing. try to take the terms which have y on one side and the terms which don't have y on the other side. I did that and I reached this point here. Once you take it, try from the terms which are y, try to take out y. You'll be left with whatever you're left with, you'll get that thing and divide both sides with that term. That's how you get your answer. Any questions, anyone, for inverse?
I'm able to understand it now.
Okay. Any doubt? Anyone wants me to explain anything we did today? So we did compositions, functions, one-to-one, and we did inverse. These are the 4 topics we did today. Any problem with these 4 topics? Everyone's good? Okay. So people I don't have attendance is was, Miguel, Joshua. Joshua is here. Joshua is here. I just marked him here. Erica is not here. Daniel, Hawking, and I mean that's it. And I want Nick to stay back. Nicholas to stay back. Everyone else can go. Thanks, guys. See you tomorrow.
Thank you.
Thank you.
Yeah.
Miss K, have a good day.
You too. Have a good day, guys. Take
You're
care.
uploading the homework today, right?
Yeah, I'll be assigning homework right now and it will be due next week.
Thank you.
Yeah.
Wait, so I was marked for attendance, right?
Yeah. I marked for you for the attendance. Perfect. Yeah.
Thank you. Have a good day.
You too. Have a good day. Okay, let me just